The average modern adult will spend approximately 38.5 days of their life brushing their teeth. 38 days. That is longer than most people spend on vacation in an entire decade. They will use approximately 300 toothbrushes, hundreds of tubes of toothpaste, and spend thousands of dollars on dental care, fillings, extractions, orthodontics, and whitening treatments across a lifetime. And despite all of that, despite the fluoride and the electric toothbrushes, and the twice-yearly professional cleanings, and the mouthwash and the floss, tooth decay is the single most widespread chronic disease in human history. More people alive right now have experienced dental cavities than any other condition on Earth. The World Health Organization estimates that 3.5 billion people are currently affected by oral diseases. 3.5 billion. That is nearly half the population of the planet, suffering from problems in their mouths, despite having access to dental hygiene tools that our ancestors could not have imagined. And here is the part that should make every dentist deeply uncomfortable. The humans who lived before toothbrushes existed, before toothpaste, before fluoride, before dental chairs, before any of it, had measurably better teeth than we do. The bones prove it. And the reason why is going to change how you think about everything you put in your mouth. Here is what your dentist has never told you. When researchers analyze the dental remains of pre-agricultural humans, people who lived before farming, before sugar, before processed food, they find something that contradicts everything the modern dental industry is built on. Cavity rates in pre-agricultural populations were between 2 and 5%. 2 to 5%. In modern populations, depending on the country, cavity rates range from 60 to 90%. The humans who never owned a toothbrush had teeth 6 to 15 times healthier than yours, not slightly healthier, not marginally better, dramatically, measurably, undeniably superior dental health. And the story of how they achieved it, without any of the tools we consider essential, is not just a history lesson. It is an indictment of something that happened to the human diet approximately 10,000 years ago, the consequences of which are still destroying teeth right now, today, in your mouth. Before we go any further, I want you to do something. Run your tongue across your teeth right now. Feel the surfaces. Think about the last time you had a cavity filled. Think about the last time a dentist told you something was wrong. Now consider this, a human being who lived 40,000 years ago, eating raw meat and fibrous plants and drinking water from rivers, with no toothbrush, no fluoride, no dental intervention of any kind. That person almost certainly had fewer cavities than you do right now. The question is not whether this is true. The evidence is unambiguous. The question is why. And the answer reveals something about modern civilization that the food industry has spent decades and billions of dollars making sure you never connect. Here is the theory that has been sitting in the dental archaeology literature for 30 years, largely ignored by mainstream dentistry because of its implications. Human teeth did not get worse because we stopped cleaning them properly. Human teeth got worse because we changed what we put on them. The toothbrush is not a solution to the cavity problem. It is a management tool for a problem that should not exist at the scale it does, and the ancient humans who had dramatically better dental health were not achieving it through superior hygiene practices. They were achieving it through a diet that their teeth were biologically designed to process, a diet that the invention of agriculture dismantled in approximately 10,000 years after 300,000 years of dental stability. But here is the part that gets strange. Because they were cleaning their teeth, just not in any way you would recognize. In 2013, a team of researchers analyzing the fossilized dental remains of Homo habilis specimens from Tanzania, dating to approximately 1.8 million years ago, found something embedded in the calcified plaque on the teeth that stopped them completely. Toothpick grooves. Deliberate, repeated, patterned marks between specific teeth, consistent with the regular use of a thin pointed implement to remove food debris from the interdental spaces. 1.8 million years ago, before Homo sapiens existed, before fire was reliably controlled, before any tool we would recognize as sophisticated, something was being used, regularly, habitually, with enough consistency to leave permanent marks in fossilized enamel to clean between teeth. Wait. If a species that predates modern humans by over 1.5 million years was already practicing interdental cleaning as a regular habit, what does that tell us about how deep this behavior goes? And what were they actually using? But the toothpick grooves are only the beginning. because when researchers started analyzing the actual content of preserved dental plaque from prehistoric human specimens, the calcified tartar that fossilizes and preserves on ancient teeth like a biological time capsule, they found something inside it that nobody expected. The plaque was not just food debris, it was a record. A detailed, chemically readable record of everything that had ever been put in those mouths. And some of what was in there had no business being there if prehistoric humans were as ignorant about oral health as we assumed. The plaque was telling a story, and it was a story about plants. Let's follow the evidence like detectives, because this investigation has a chemistry to it. In 2012, a landmark study published in Nature Genetics by researcher Laura Weyrich and her team at the Australian Centre for Ancient DNA analyzed the preserved dental calculus, fossilized plaque, from Neanderthal specimens across multiple European sites. What they found was extraordinary. The calculus from a Neanderthal specimen found at Spy Cave in Belgium contained residues of woolly rhinoceros and wild sheep, consistent with a meat-heavy diet in a cold northern environment. Expected. The calculus from a Neanderthal specimen found at El Sidrón Cave in Spain contained something completely different. No meat residue. Instead, poplar bark, which contains salicylic acid, the active compound in aspirin, yarrow, chamomile, and something else. Penicillium, the mold from which penicillin is derived. This Neanderthal, 50,000 years ago, was consuming plants with known antibiotic, anti-inflammatory, and analgesic properties. And crucially for our story, several of these plants also have documented antimicrobial effects on oral bacteria. The researchers concluded that this individual was not eating these plants for nutrition. They were using them medicinally. Which means Neanderthals, 50,000 years before the first pharmacy, had identified specific plants with therapeutic properties and were deliberately consuming them for their effects. Now apply that finding to dental health. If Neanderthals were selecting medicinal plants based on their biological effects, is it so surprising that prehistoric humans would also identify and use plants with antimicrobial properties for oral hygiene? Because the ethnobotanical record, the documented plant use of indigenous cultures studied before contact with modern medicine, shows exactly this across every continent, consistently and independently. Neem tree twigs in South Asia and Africa. Salvadora persica, the miswak or chewing stick, across the Middle East, North Africa, and the Indian subcontinent. Oak bark in Europe. Tea tree in Australia. Each of these plants was used as a teeth-cleaning implement in its local culture. Each of them has since been confirmed by modern pharmacology to contain compounds with genuine antibacterial, antifungal, and anti-inflammatory properties. The people chewing these sticks were not performing a cultural ritual. They were applying pharmacologically active antimicrobial compounds directly to their tooth surfaces and gum tissue, every single day, for thousands of years, with no laboratory telling them it worked, because their teeth told them it worked. The miswak, the chewing stick made from Salvadora persica, has been studied extensively by modern dental researchers, and the findings are remarkable. A 2003 review published in the Journal of the American Dental Association analyzed 17 controlled clinical studies on miswak use and concluded that it was at least as effective as a conventional toothbrush for plaque removal and superior to a toothbrush for reducing gingival inflammation. The active compounds in Salvadora persica include benzyl isothiocyanate, a potent antibacterial agent, trimethylamine, which has been shown to inhibit bacterial growth, fluoride at naturally occurring concentrations, silica as a mild abrasive, and salvadorine, which has demonstrated antimicrobial activity against the specific bacterial strains most associated with dental cavities. The World Health Organization has explicitly endorsed the miswak as an effective dental hygiene tool. The tooth-cleaning plant that prehistoric humans identified thousands of years ago, with no laboratory equipment, no pharmacological training, and no clinical trials, has been validated by modern science to do exactly what they were using it for. And here is the critical data point for the cavity comparison. The bacterial strain most responsible for dental cavities in modern humans is Streptococcus mutans. It thrives on simple sugars, specifically the fermentable carbohydrates that became dietary staples after the agricultural revolution. Pre-agricultural humans, eating a diet without significant refined sugar or starchy grain products, were not feeding the primary cavity-causing bacteria at any meaningful scale. Their oral microbiome, the community of bacteria living in their mouths, was fundamentally different from ours, not because they cleaned better, because they ate differently. Think about what the agricultural revolution did to the human mouth in a single generation. For 300,000 years, Homo sapiens ate a diet of meat, fish, fibrous vegetables, roots, nuts, and seasonal fruits. Foods that required significant chewing effort, produced natural salivary buffering of oral pH, and did not provide readily fermentable substrate for cavity-causing bacteria. Then, approximately 10,000 years ago, grain cultivation became the dietary foundation of human civilization. Wheat, barley, rice, corn, millet. Foods that are rich in fermentable starches and simple sugars that adhere to tooth surfaces, that dramatically lower oral pH, and that feed Streptococcus mutans with exactly the substrate it needs to produce the acids that dissolve tooth enamel. The dental archaeological record captures this transition with devastating clarity. A 2014 study published in Nature Genetics by researcher Alan Cooper and colleagues analyzed the oral microbiome preserved in dental calculus from specimens spanning 10,000 years of human history. What they found was a stepwise collapse of oral microbial diversity. Pre-agricultural humans had a rich, complex oral microbiome with many competing bacterial species, none dominant. After the agricultural revolution, that diversity crashed. Cavity-causing bacteria became dominant. The oral microbiome has continued to narrow and deteriorate with each major dietary shift, the Industrial Revolution, the introduction of processed foods, the proliferation of refined sugar. The human mouth, Cooper's team concluded, is now hosting a microbial community fundamentally different from the one it evolved with. And that difference maps almost perfectly onto the modern cavity epidemic. I want you to feel what prehistoric dental hygiene actually was. You wake up before dawn. Your mouth tastes of sleep and last night's meat. There is no bathroom, no tap, no toothbrush waiting on the counter. You reach for the bundle of miswak sticks you keep near your sleeping place, the same type of sticks your mother showed you how to prepare, the same type her mother showed her, going back further than anyone can remember. You peel the bark from the fresh end with your thumbnail, chew the exposed wood until the fibers soften into a brush. The taste is sharp, slightly bitter, faintly medicinal. You work it across your teeth and gums, the fibrous end acting as both brush and chemical delivery system simultaneously. Your saliva is mixing with the plant compounds. Your gum tissue is absorbing the benzyl isothiocyanate. The bacteria on your tooth surfaces are encountering a chemical environment they cannot survive in. You don't know any of this. You know your mouth feels clean. You know your gums don't bleed when you do this. You know the people who don't bother lose their teeth earlier. That knowledge is enough. You spit, rinse your mouth with water from the clay pot beside you, and begin your day. Your teeth, at 40 years old, are worn from decades of heavy chewing. Prehistoric teeth show significant occlusal wear, but they are intact, functional, and largely cavity-free. Your modern counterpart, who has brushed twice daily with fluoride toothpaste for 40 years, has had 3 fillings, 1 root canal, and is currently waiting for a crown. Something went wrong, and it wasn't the toothbrush that fixed it. But the miswak and the diet are only part of the story. Revelation 1. Analysis of dental calculus from prehistoric specimens across multiple continents has found evidence of deliberate use of charcoal as a tooth-cleaning abrasive. Activated charcoal has documented adsorbent properties. It binds to organic compounds including bacterial toxins and some acids. The prehistoric humans rubbing charcoal on their teeth were not doing it for the aesthetic of white teeth. Charcoal doesn't whiten teeth. They were doing it for an effect they had empirically observed, and the chemistry explains what that effect was. Revelation 2, a 2019 study analyzing dental calculus from Iron Age specimens in Britain, found evidence of deliberate use of specific mineral clays as oral abrasives. The clay particles had a particle size and mineral composition consistent with intentional selection, not random ingestion. The researchers concluded that these individuals were using clay as a polishing and antimicrobial agent on tooth surfaces. Mineral clays with antimicrobial properties, selected and applied deliberately to teeth, approximately 2,500 years ago. Revelation 3. And this is the one that forces a complete reevaluation of everything. A 2021 paper published in the journal Science Advances analyzed the complete oral microbiome preserved in dental calculus from specimens spanning 100,000 years of human history and found that the single most significant predictor of oral microbial health was not hygiene practice. It was not cleaning frequency. It was not the tools used, it was diet composition. Specifically, the ratio of fermentable carbohydrates to fiber and protein in the diet explained more variance in oral health outcomes than every other factor combined. The cavity is not primarily a hygiene failure, it is a dietary consequence, and we built an entire industry around managing the consequence instead of addressing the cause. Here is the question that the dental and food industries have a shared financial interest in never asking directly. If the evidence clearly shows that the primary driver of the modern cavity epidemic is dietary, specifically the agricultural and industrial introduction of fermentable carbohydrates and refined sugars that pre-agricultural humans never consumed, then why is the entire public health response to dental disease focused on improving hygiene rather than changing diet? The answer involves an uncomfortable intersection of industrial food production, dental industry economics, and public health messaging that has remained largely unchanged since the 1950s. Fluoride in water prevents cavities. Toothpaste prevents cavities. Regular dental visits manage cavities. All of these things are true. None of them address why 3.5 billion people have oral disease in a world where those interventions are widely available. The prehistoric human didn't need fluoride in their water. They needed a diet their teeth were built for. We built a civilization on foods their teeth were not built for, and then invented a hygiene industry to manage the damage. The prehistoric human chewing a miswak stick didn't have a better toothbrush, they had a better problem. But here is where our modern understanding of dental health completely fails us. We treat the toothbrush as the solution. The evidence suggests the toothbrush is the apology for what we put in our mouths. The prehistoric human who never owned a toothbrush and had better teeth than you is not an anomaly. They are the baseline. We are the deviation. And every filling in your mouth is a data point in an experiment that started 10,000 years ago when the first grain was ground into flour and the first bread was baked, and the bacteria in human mouths had their first significant evolutionary advantage over human enamel. Here is the assumption most people carry into this topic, that the history of dental health is a story of progress. That we started with terrible teeth and gradually, through the development of dental hygiene, improved. The archaeological record tells the exact opposite story. Pre-agricultural humans had excellent teeth. Agricultural humans had worse teeth, dramatically worse, within a few generations of adopting grain as a dietary staple. Industrial humans have the worst teeth in 300,000 years of human history. The progression is not improvement. It is a continuous decline, punctuated by hygiene interventions that slow but do not reverse the trajectory. The miswak-chewing prehistoric human at 40 years old, with worn but cavity-free teeth, was not the primitive starting point of a story that ends with modern dentistry. They were the high point, and everything since has been a managed retreat. This is what the dental calculus has been trying to tell us for 30 years of increasingly precise analysis. The 1.8 million-year-old toothpick grooves, the Neanderthal calculus containing medicinal plants, the miswak compounds that match modern pharmacological standards, the microbiome data showing stepwise collapse with each dietary revolution, the cavity rate comparison, 2 to 5% pre-agricultural versus 60 to 90% modern, that no hygiene intervention has come close to reversing. Taken together, these data points tell a single coherent story. The human mouth evolved over millions of years in a specific dietary environment. That environment produced a stable oral microbiome, minimal cavity incidence, and teeth that remained functional across a lifetime. Approximately 10,000 years ago, we changed that environment faster than evolution could respond. The oral microbiome destabilized. Cavity-causing bacteria found an unprecedented food supply, and we responded by developing increasingly sophisticated tools to manage the resulting damage, while continuing to eat the foods causing it. The toothbrush is one of the most successful products in human commercial history. It is also, in a very precise sense, evidence of one of the most consequential dietary mistakes our species ever made. We invented the problem. Then we invented the product to manage it. And then we forgot we invented the problem. The miswak is not a historical curiosity. It is a pharmacologically validated dental hygiene tool that is currently used by an estimated 700 million people worldwide, primarily in Muslim-majority countries where its use is tied to religious practice. The Prophet Muhammad is recorded as having used it regularly, and its use is recommended in Islamic tradition. Clinical studies comparing miswak users to toothbrush users consistently find equivalent or superior outcomes for miswak users on plaque scores, gingival health, and bacterial load. The chewing stick that prehistoric humans selected thousands of years ago has been continuously validated by every pharmacological tool modern science has developed. It works. The broader implication is harder to act on but equally clear. The research on diet and oral health suggests that reducing fermentable carbohydrates, specifically refined sugars and processed grain products, has a more significant impact on cavity risk than any hygiene intervention currently recommended by mainstream dentistry. This is not a fringe position. It is the conclusion of the most comprehensive microbiome and dental archaeology research currently available. We are not brushing our way out of this problem. We are eating our way into it, twice a day, every day, and then reaching for the toothbrush to apologize. The prehistoric human chewing a miswax stick at dawn did not know what benzyl isothiocyanate was. They did not know what Streptococcus mutans was. They had no concept of oral pH, bacterial biofilm, or enamel demineralization. What they had was something we have largely lost, an unbroken chain of empirical observation, passed from generation to generation, about what actually worked. Not what a product label claimed, not what an advertisement promised, what their mouths and their parents' mouths and their grandparents' mouths had demonstrated over lifetimes to be true. The people who came before writing, before laboratories, before clinical trials, they were running experiments. Every day, in their own bodies, they were testing what worked and what didn't, and the results of those experiments were encoded in their practices, their plant selections, their dietary habits, and passed forward with a fidelity that no marketing campaign has ever matched. They didn't have our tools. They had something rarer. They had unmediated feedback from their own biology and the wisdom to listen to it. 1.8 million years ago, a human ancestor pushed a thin wooden implement between their teeth and removed a piece of food. That habit, that specific, practical, daily behavior, left marks in fossilized enamel that survived long enough for a researcher in 2013 to find them and understand what they meant. The behavior is older than our species. The need it addressed is older than fire. And across 1.8 million years of that behavior, the human mouth was doing reasonably well. Then, 10,000 years ago, we invented agriculture. And then we invented the toothbrush to manage what agriculture did to our teeth. And then we invented the dental industry to manage what the toothbrush couldn't fix. And then we invented fluoride to manage what the dental industry couldn't prevent. And 3.5 billion people still have oral disease. So here is the question that 1.8 million years of dental history is asking you. If the prehistoric human with a stick and a different diet had better teeth than you, what exactly is all of this for? And what would you have to stop eating to find out?